I want to show you how to use a feature in Excel called a what-if data table. We're going to use it to do a heat map or contours of a regression optimization, but you can use it for lots of other things too. So we want to compute the sum of squared residuals at a bunch of different intercept and slope estimates. So here I've got some plain data. Here's my prediction. It's the intercept plus the slope times the y value. That should be the x value, shouldn't it? That's a mistake lots of people make, and I guess I'm one of lots of people. Okay, there we go. And then the residual is y minus the prediction. And here we're doing the sum of squared residuals. It doesn't have to be sum of squares. It could be sum of absolutes or pretty much any other function you want there. So I'm going to say, let's try a bunch of different intercept estimates. And let's do like -1, -0.5, etc. And slope estimates. I'll say -1, -0.5. It doesn't have to be the same. In fact, let's make it not the same either way. Let's do that. It doesn't have to be integers, for example. So I'm going to do things really small here, like that, just so you can see it, and then I'll do it at a larger scale that's more useful. So I'm going to, in this, notice how I laid this out. I've got a column of possible intercepts, a row of possible slopes, but with a blank cell at the intersection of that row and column. I'm going to say equals this, and then I'm going to highlight the table, including the possible slopes and possible intercepts and slopes and the objective function value. I'm going to go to the Data tab and do what if data analysis. If your ribbon is really small, you might just see a question mark here, and I'll click on that, and I want a data table. And it wants to know where should it put the row, the stuff from the rows. We want to put, those are slopes, and so we want to put that here. That was our slope estimate place. And where should it put the stuff from the columns? It should put those here. When I hit OK, it's going to take this intercept and paste it there, take this slope and paste it there, and then it will look at whatever's in the cell, which happens to be that, and put the value of it here, because it just picked up this number and that number. Then it will take this number for the intercept, that number for the slope, paste it here and there, look at this result and put it there, etc. So it's basically a double for loop, if you know programming, a very simple and constrained one. So I'll hit OK, and it puts a bunch of numbers there. It's kind of interesting to see what the formula behind that is. There's a bit of magic going on here, because we didn't exactly tell, I mean, this formula doesn't exactly say where to get the numbers from and where to get that number from, but somehow it works in Excel. So we can see here, where's our minimum sum of squared residuals? I guess that one or that one. Interesting that those are pretty similar. So now let's try it with more possibilities for slopes and intercepts. So I'm going to say like -0.9, for example, and then I'm going to drag this down, and let's go up to 1.5. And here we'll use -1, -0.95. Let's try. They don't have to be the same from rows to columns. And let's go up to, let's see, that's probably good. And then if I try to just delete one of these, it'll say you can't change part of a table. I have to highlight the whole thing and delete that. And now I'll highlight that whole thing. I'm going to zoom out so I can see stuff. And say what if analysis, data table, row input cell, that was the slopes, column input cell, that was the intercept, and there we go. And now we've got a bunch of numbers. It would be nice to visualize what's going on. One quick way to do that is to highlight the body of the table, not the side column stuff, and go to Home, conditional formatting color scales, and this will color the smallest value in the table one thing and the largest value in the table another thing, and do a smooth interpolation between them. In this case, small values are good, so I'm going to use blue for the smallest and red for the largest. Try to avoid using scales that use both red and green, because red-green colorblind is the most common kind of colorblindness. So here we can see, oh, these numbers are, hey, that's pretty small, 0.06, and then over here we're up in the hundreds. So that's a nice way to visualize stuff using conditional formatting. Another way to do stuff is to do a contour plot or a 3D plot. They aren't that great in Excel, but they might be better than nothing. The tricky part is if we just highlight those and say insert, let's see what it recommends. A surface. We could try a surface. That kind of works, but see what the x-axis labels are, just numbers that aren't the slope and intercept values we put in. This is just counting rows of the table. We'd like to have it use all those rows of the table, but if I do this, it will treat the numbers in the row and the column as if they're data values rather than labels for the x and y axis. What we need to do instead is make a copy of the table. You could do it by copy paste, but it's better, I think, to use an equal sign and say equals that cell up there. Let's see. We don't need that one. And then we'll just fill that over. And I think I missed the slope values here. So this looks like basically the same thing as we had up here, but that one little corner thing is missing, and that, having a blank there, will be the key that Excel looks for to decide whether it should use these values and these values as x-axis and y-axis labels or as data values. So let's try this. Insert recommended charts. All charts, surface. And you can kind of see there the x-axis is actually using decimals, and so is the other horizontal axis here. You could also use, let's see, if you do surface, but then something that's not one of these 3D views, but just top-down view, you can get other contour plots there. Again, not the most wonderful thing, but at least now you know how to do what-if tables and sort of 3D diagrams in Excel. One other thing to point out, notice when it was putting these numbers here, I had typed zeros here, and there's still zeros there. If I put something like 0.5 or 0.4 here, it gives me the new sum of squared residuals for that, but it doesn't affect what was in the tables. For the tables, it kind of takes these two, picks them up, saves them somewhere, does all the table calculations, and then puts these back and puts that number back, kind of transparently. Calculating tables can take a long time. Here I only have 30-some, 20-some residuals, so it went pretty fast. But if you've got calculations that go on for hundreds of thousands of rows, the table can be pretty long. What you can do is under the Formulas tab, under Calculation Options, it's usually set to automatic, so it recalculates everything that needs it once a number changes on the spreadsheet. You can change it to automatic except for data tables, and then it won't recalculate the data tables when you don't want it to, and you can tell it to recalculate by hitting Recalculate Now or F9 on a Windows machine, probably Control equals on a Mac. So you can also do one-dimensional data tables. Like here, I could say if I just wanted to change the intercept values, then, and here's a slightly interesting thing. for the 2D table, I put the objective function or whatever function I want right here, but for the one-dimensional table, I put it there. And then highlight what I want and say insert, not insert, data, what if, data table. And now I have a column, so I enter something in the column input cell, but I don't enter anything in the row input cell. So it did basically all that same thing we did here, but it only changed this and only changed the intercept. And if I change the slope estimate here, then all these numbers changed because now the slope estimate is much bigger than it used to be. All right, send me email if you want to know more about what if data tables. You can use them on stuff that does random calculations, and it's kind of a way of doing multiple trials with random numbers.